So good morning everyone. I'm Rain and my goal is to help you, the electric consumers, manage your electricity bill in a way that has never been done before in the Philippines. Let me show you how. For a moment, I'd like you all to recall. When was the last time you or your family aimlessly limited the use of your aircon, TV, or any other big appliance in your house in an attempt to save electricity? Or maybe, when was the last time you're expecting a bill of only around 5,000, only to be surprised as you receive something around 7,000 or even more? Pabalik. 7,000 or even more. You see, these common experiences of ours exhibit the kind of electricity management system that we have in the country. It's a guessing game. This makes managing our electricity very difficult, and I know you can feel what I feel. Because we almost purely rely on our electric bill, which only arrives at the end of each month, during which any adjustment to our consumption lifestyle is already too late. And for something as important to Filipinos as electricity and budgeting, this shouldn't be the case. Hence this study on non-intrusive appliance recognition system. You can call it Smarter Meter for short. Smarter Meter is an electricity consumption monitoring platform that allows the user to do two things. First, it allows the users to access their electric consumption data in real time, thereby allowing the user to check their electric bill as it accumulates any day within the month. Second, it breaks this total consumption data into the constituent appliances that makes up that aggregate total. This allows the user to see which appliances consume how much electricity and how that translates to financial cost for the user. So these two functions altogether provide a profound level of energy management capability for the user. So how does Smarter Meter work? Imagine this is your house. You own several appliances, each connected on different sockets into the house. These connections converge into the main power line that enters your residence through the circuit breaker. So the current that we could measure from that main line should be the sum of all the currents consumed within the household, of all the appliances. This is what we refer to as the aggregate current. Now, in order to measure this aggregate current, I use a non-intrusive clamp current sensor, which is a plug-and-play device that measures current via electromagnetic induction. So using this, we could already achieve the first function of Smarter Meter, which is to measure and present the total consumption of the user, and then present it through the user by throwing this data into the cloud server and then giving access through the user through a mobile app. So how then do we achieve the second function, which is appliance recognition? Do we have to attach one of these sensors onto every appliance in the household? Well, not exactly. But imagine how expensive it will be for the user if we'd have to dedicate one sensor for every appliance in the household. You see, one of the key innovations of this study is the utilization of one sensor, just one, connected to the circuit breaker, but one sensor to measure or detect multiple, if not all, appliances within the household or electric domain. So, let me elaborate. Appliances are circuits and are therefore ultimately characterized by their resistance, inductance, and capacitance characteristics. Because of this, different appliances interact with electricity in a different way, unique to that particular appliance. This unique electrical response is what we refer to as the appliance signature. From here, we see that once these signatures converge into the main power line, they additively combine, as noted by the superposition principle of the Fourier domain. Now, the premise of my study is a reversal of this process. In my case, given the total current, I want to be able to identify the constituent currents that makes up this total. If I could identify the constituent currents, I could identify the appliances that are actively present during that time period. In order to accomplish this, I trained a classifier model using machine learning to do the necessary complicated operations needed to perform this task. But before this, we must first gather data of each appliance for training. Unfortunately, the Philippines do not have a data set ready for all the appliances we have, so we have to collect our own. And given that I'm in the undergraduate level and I have to train my own machine learning models, I have to collect my own data in a specific scope. So collecting data for every appliance could be a very tedious process, especially if we're looking for specific characteristics. In order to resolve this problem and streamline the process altogether, a separate hardware system was developed to automate or semi-automate this data gathering procedure. This system is what I refer to as the Semi-Automated Data Acquisition System, or SADA, and is the second key innovation of this study. Afterwards, 6 pre-processing techniques were developed or implemented in order to either boost the speed or improve the accuracy of the output of the learning model. The question now is, how then do we get data to represent the case of simultaneously operating appliances? Traditionally, we'd have to collect or connect every possible configurations of those appliances within our scope. For example, in this room, if we say we have 7 appliances in this room that we want to recognize, then we'd have to get data from all the 128, that's 2 raised to 7 plus 1, 2 raised to 7, different combinations of those 7 appliances to account for them in the training process, which is obviously very tedious. However, during the study, it was found that the signals of simultaneously operating appliances, could be approximated by adding the individual signals together artificially. Now, instead of collecting all of the 128 different combinations of those 7 appliances, as I said before, I'd only have to collect the data from each of the appliances that I have within my scope, and then artificially generate the rest in training. This greatly cuts down on data gathering time, therefore expanding the scope and the results even further. So this method is what we refer to as the method of mixtures, and is the third key innovation of this study. So, given these, I've identified my electrical domain, my domain in the study as shown, in the 7 appliances as shown. So here we want to see if the models could identify 2 appliances of different brands but similar ratings. 1 appliance that have different settings, like hair dryer on medium and hair dryer on high, or appliances that switch states during operation, like rice cooker when it's cooking, then it switches to warm. I want to know if it could identify those cases. Results show high cross-validation accuracies and considerable F1 score, therefore affirming the reliability of the models in each of the cases identified. Furthermore, the converging learning curves further prove the generalizability of the models, neither overfitting nor underfitting. And an average training time, in terms of average training time, it only took the model approximately 1.5 hours to generate all the 7 classification models, each having 7,500 different training examples. So to conclude, the system is easy to install and affordable thanks to the plug-and-play single sensor implementation and the SADA system. And our results affirm the reliability and the scalability of the study. So in the end, I believe that innovation is not just about creating something that the world has never seen. At its core, it should be about building something so that we could all see a different world. As an engineer, I believe that the research that we do should not be confined within the 4 corners of the laboratory or inside the manuscript dusting on some shelf in the academy. We started our research with a problem statement that we identified out there, and therefore the solutions that we offer should always find itself outside as well. This has been our motivation, and thankfully, thanks to the different people and opportunities that came in our way in the past few months after graduating last June, my team and I were able to generate or to gather more than enough funds and support to push this study into an actual startup. Given these, we were able to further develop the study in terms of system, operation, and interface. So this is, and actually just last week, we were able to finally deploy to our first ever paying customer. So this is just a small step, but it's a step towards the right direction nonetheless. I believe that initiatives like these are important, not only in the personal or household aspects or business aspect, but more importantly, to the countrywide extent as well. Imagine if we in Smarter Meter could help just one household save a meager 10 kilowatt hour every month. That's the pessimistic case, less than 2.5% of the country's average consumption in household case. Let's say we could help them save 10 kilowatt hour through our system. How much energy could we save the country if we could reach 10, 100, 1,000, 10,000 or more households? And that's just the households. What if we could expand to the commercial? What if we could reach the industries? What if the smarter solution to the energy problems that we are facing in the country right now is simply a country of smarter consumers? That was my vision during my research, and that is now the mission of Smarter Meter. Thank you very much for listening.